What is an intrinsic and extrinsic semiconductor? An intrinsic semiconductor is a poor semiconductor material like silicon or germanium without any impurities. In this type, the number of electrons is equal to the number of holes and the conduction electrons due to thermally generated charge carriers. An extrinsic semiconductor is formed by adding small amounts of impurities to a poor semiconductor to increase its conductivity. If pentavalent impurity is added, it becomes an N-type semiconductor with electrons as majority carriers. If trivalent impurity is added, it becomes a P-type semiconductor with holes as majority carriers. Explain the formation of p-n junction. A p-n junction is formed when p-type and n-type semiconductor materials are joined together. When they are connected, electrons from n side diffuse into p side and combine with holes. Similarly, holes from p side move to the n side. This movement creates a depletion region near the junction where no free charge carriers exist. An electric field is developed across this region which opposes further diffusion. This region acts as a barrier and controls the flow of current in the diode. What is superconductivity? Superconductivity is a phenomenon in which certain materials show zero electrical resistance when cooled below a specific temperature called the critical temperature. In this state, electric current can flow without any energy loss. Superconductors also expel magnetic fields from their interior, a phenomenon known as Meissner effect. Superconductivity has an important application in MRI machines, magnetic levitation trains, and particle accelerators. What is population inversion in lasers? Population inversion is a condition in which the number of atoms in an excited energy state is greater than the number of atoms in the ground state. Normally, more atoms stay in lower energy state. In lasers, external energy is supplied through a process called pumping to achieve population inversion. This condition is necessary for stimulated emission, which produces coherent and intense laser light. What is polarization in dielectrics? Polarization in dielectrics refers to the alignment of electric dipoles inside an insulating material. When it is placed in an electric field, the positive and negative charges inside the atom shift slightly in opposite directions. This creates dipole moments within the material. Polarization reduces the effective electric field inside the dielectric and increases the capacitance of capacitors using dielectric materials.